y'all! Welcome to another episode of Modem Monday. This month I wanted to talk about what is most likely the oldest designed modem in my collection. It is so old that it predates RS-232, it does not use current loop, it only works with teletypes, and you might stop me right there and say, but you just said, well, you'll find out. So a little bit of background, this is a dataset 101C. It traces its roots back to the original Bell 101, which was developed in 1958 for use in the SAGE project with the US Air Force. The internet claims that this is a 101, but I'm not so convinced. Yeah, it has a digital subscriber set. That might be the dataset. The thing that makes me question the photo is the other half of the apparatus with the recorded carrier subset. What is a recorded carrier subset? Why does it have a tape deck on top of it? Why are there two phones? But beside the point, the 101 was the first commercially available modem. It was also the first commercial equipment to use ASCII, which is the basis of how we communicate in the digital world even today. But for this video, we'll specifically be looking at the 101C. The 101C traces its roots back to that original 101 from 1958 and appears to have come into existence in about 1961. There were three different versions of the 101 as best as I can tell, and those were the 101A, B, and C. The A could be upgraded to a B, the B could be upgraded to a C. Each of them had different reasons as to why you would need that revision of the modem. This one appears to have been upgraded from one type of C to another. You can see here where someone marked out the original designation and stamped a new designation to the left. Then it appears that they tried to paste something over the old designation. I would assume that that's the configuration worksheet that's supposed to be attached to every 101 dataset. According to the documentation, the standard station arrangement consists of dataset 101C, attendant circuit, and a 33 or 35 type teletype. So what are the parts of the 101C? The 101C contains 7 cards. The first is the discriminator. The discriminator is essentially the demodulator for the system. It determines if there was a shift in frequency on the received carrier signal and translates that into data. The modulator, which is fairly self-explanatory, it's exactly what you would think. Any data you're trying to transmit out of the unit then gets modulated into a carrier wave. The hybrid, if you know anything about telephone equipment, you probably know what a hybrid circuit is already, but the hybrid is responsible for matching the impedance of the device to the telephone network and splitting the transmit and receive on and off of the 2-wire pair that runs out to the telephone network. The limiter is responsible for restricting the amount of volume that the modulator can push into the hybrid and out to the phone line. This prevents the modulator from overdriving the signal to the remote end, which could cause distortion and bit errors. This is also used as a way to overcome losses in the line back to the central office to set it to a standard so that the volume is always the same regardless of where the station calls to. The timer. The timer is half of the automation brains for the unit. It provides all of the timing signals that other cards and other logic use to determine how much time has passed. This gets used primarily in things like carrier detection. Whenever the system goes into answer mode, because a ring was detected, it will go off hook and wait 8 seconds to try and detect a carrier. If no carrier detection comes in, then the timer circuit causes the call to go back on hook. The send break timer. Now this is a special timer. It's used for break communications. A break gets sent by the remote station if for some reason you need to stop the local station from sending. In the case of the send break timer, when you press the break key, it needs to tell the modulator to send a signal that equates to the timing of the break. On a received break, this card also handles the release of the break. The restrainer. The restrainer is an interesting piece of equipment. You have to think about the fact that when this equipment first came out, it was the first of the 100 word per minute equipment that was available. There was a lot of 60 word per minute or even slower equipment that was out there. Inside central offices, there were pieces of equipment that would allow faster and slower teletypes to speak to each other. In the event that a 100 word per minute equipment was trying to communicate with the 60 word per minute equipment, you could not transmit at full speed. So it became necessary for this translation equipment at the central office to be able to tell the sender to slow down, kind of like modern flow control would be. In order to do this, whenever the intermediate equipment starts to realize that the sender needs to slow down, its carrier wave begins to warble with a 50 Hz modulation. So as soon as that equipment needed the transmitter to slow down, it would start to warble its carrier wave, which would enable the restrainer relay on the sending equipment and illuminate a light. And this would either stop the tape reader from sending, or it would block the keyboard from being able to send any more characters until the warble went away, because the equipment could transmit more data to the slower endpoint. Additionally, there are 9 control relays in the backside of the data set. These are the AN, the CON, the M, the OR, the S, RU, CY, RB, and RS relays. When you observe the operation of the equipment, it becomes obvious what some of these relays are for, especially when given the hint of the lettering on the relays. AN starts the dataset into the answer mode. CON signifies that a connection is detected. M enables the modulator. OR begins the originate mode. S enables or disables the speaker. RU enables or disables the run condition of the teletype. CY has something to do with carrier loss detection. RB is receive break. And RS is restrain. There are two 25-pair cables that connect between the teletype and the dataset. You can see here where the two 25-pair cables connect to 50-position terminal strips inside the back of the dataset. Down the center is a 60-position terminal strip which contains various signals for the dataset itself. All connections to the teletype, the phone line, and configuration happen at these terminal strips. This whole system precedes RS-232 by several years. It doesn't even work current loop the same way as what you would expect from most teletypes. Internally to this teletype, all of the current loop is generated in both 20 and 60 milliamps, and the two levels of current signify mark and space. All of these signals can be routed independently, depending on what mode the apparatus is in. It is possible with this system on a 35 ASR to receive text to the printer while sending from the tape reader, while preparing a punched tape from the keyboard. Now, a teletype that's been configured to use a dataset can and can't be easily converted back to a private line configuration. In the case of a Model 33, it's relatively simple because of how simple that machine is. You can remove the dataset, remove the call control unit, remove the attendance set, and install a standard UCC6 call control unit into the Model 33 and make it back into a private line unit. However, in a Model 35 ASR, because of the complexity of the system, you would need a lot of parts that only belong to non-dataset equipment, including a different ESU, a different front panel, a different call control unit, and those parts are very hard to find since they're specific to the ASR model of the 35. Okay, so now we've talked a bit about what the dataset is, what all the pieces of it are, how it all works together. But what about the specs of this system? Well, it's 110 bits per second. That's 100 words per minute or 10 characters per second. It uses an 11-bit asynchronous serial communications. That is to say that this unit is configured for 8N2. That's 1 stop bit, 8 data bits, no parity bits, and 2 stop bits. That works out to 11 bits. It's designed to be used on the 2-wire public switch telephone network, and it has flow control in the form of the restrainer circuit that we discussed earlier. Since the dataset can't be used without a teletype, and there's already so little information on YouTube about the 35s, especially the ASR version of the 35s, let's cover some basics about the 35 ASR. The units that make up the ASR are the call control unit. The call control unit is partially power supply, partially cross-connect for cabling. Contrary to its name, it doesn't actually control a call as though a telephone call. The electrical service unit. The ESU has a wire field in it. It's covered in this picture. The big brown rectangle covers the wire field, but that's the cross connect for all of the various electronic components of the teletype itself. It also contains 2 circuit boards and a few routing relays that switch the mode of the system into different operating methods. The typing unit is the thing that actually prints text to paper. The keyboard and base units, the typing unit mounts on top of the base unit. They share a drive shaft and a motor, but other than that, there are no mechanical connections between the two of them, and there are no direct electrical connections between them. Check the description in this video. I'll put a link to a slow-mo close-up video of the sender unit of the keyboard on a Model 35. It's a very interesting little widget. It is actually a mechanical shift register where it takes the parallel data that is given to it by pressing a key on the keyboard, and it skims through it mechanically and serializes that data. As it serializes that data, it literally telegraphs that information by moving a key back and forth. The answer back unit, this is also known as Here Is or Who Are You? It's an automated sender that has a drum in it with little plastic tabs that can be broken off to create bytes on its little drum. And whenever it gets triggered, it cycles through and it transmits every single one of those bytes to the remote end. This automatically gets triggered whenever the teletype answers a call so that it can identify the station that got called. The same unit can be triggered manually by the teletype operator by pressing the Here Is key. This is the reperforator. That's kind of a fancy way of Teletype Corporation saying the paper tape punch. This thing takes 8-bit ASCII code and punches it into a row on the tape for later retrieval. The density of this tape is about 10 bytes per inch, and so a 100-foot roll of this tape will hold just under 12 kilobytes of data. This is the transmitter distributor. It's another fancy teletype word for paper tape reader. Because this unit is in a dataset configuration, it is much more flexible than a standard private line style 35 ASR. It has a different mode selection key set than a standard unit because it can do multiple things at once, unlike a standard unit. These modes operate differently in half duplex versus full duplex. My machine is set up for full duplex because that's what I need for the way that I use it. So I will describe the functions as they pertain to full duplex. In the K mode, the keyboard transmits data remotely. Any incoming data gets printed to paper. In the KT mode, the keyboard transmits data to the remote end, and incoming data gets punched to tape and printed to paper. In the T mode, the keyboard punches to tape, and any incoming data gets printed to paper. In TTS mode, you can send from the tape and no incoming data gets punched or printed. In TTR mode, you can receive to the tape punch, but you cannot send or print anything. The motor on is not a key, but rather a twist-on switch. This leaves the teletype's motor running regardless of what the dataset would like for the teletype to do. This is very handy for operators that are preparing punch tape from the keyboard. If a call comes in while they're doing this, the machine will continue running after that call disconnects. TD call in is another twist knob. I think what this is supposed to do is make it to where it will automatically send a tape whenever a call is answered. I have not been able to make mine do that. Maybe there's still something that's wrong with the data set that I haven't diagnosed yet. I don't really have a use for this feature, so I'm not too worried about it not working if that's how it's supposed to work. The next two buttons are TD off and TD on. These turn off and on the paper tape reader, the transmitter distributor. And if you're in a mode that you can send from tape, pressing TD on starts it. And if you press TD off, it stops it. ROTR, this is the typing reperforator unit. It's an external unit that I don't have, but the button is still included here for the people who ordered it along with. What this permits you to do is to perforate a tape, and on the same tape, it prints the letter or the number on the location of each byte as it goes through the reperforator. Here Is the manual trigger for the answer back drum to send the station notification to the remote end. Break, and break is how you send a break to the other end. Whenever you send a break, it causes the other machine to stop sending. And once that machine has stopped sending, it will not resume transmission to your station until the operator on that end manually presses the brake release key. Now the attendant set for the data set is this little bar down the side of the console for the teletype. This allows you to control the phone line. It allows you to control the mode of the data set as well as the teletype. It also has these other things up above, like the brake release key, which I just mentioned. When the machine stops because your end has been broke by the far end sending a brake signal, you can then resume operation of your machine by pressing the brake release key. The next one is rest. This indicates that the restrainer condition has been enabled to do flow control against you because you're sending too fast for the equipment that's receiving you. Out of service. Out of service is a way to make the system stop answering phone calls. If you do not want it to automatically answer, you put it to out of service, which is just rotating the black arrow knob next to it to point to the out of service light, which lights up the light and ceases automatic answer. It will then latch in that position until the operator moves it back to normal. There is a momentary position called restore, which if you turn it to that location, it will let you monitor the phone line so you can see if you're hearing a dial tone and if you're clear to start using the phone again. On the bottom side, there's the volume, which is self-explanatory. It sets the volume of the speaker that you're monitoring call progress with. There's a rotary dial, which is also self-explanatory. You can use this to dial the station that you want to communicate with. The originate key places the unit into originate mode. It will pick up the phone line, turn on the speaker, allow you to dial, and then it will wait for a carrier. Once the carrier is detected, the speaker will turn off and the machine will enter into T mode. Clear is the button to shut down the machine. So if you're in answer or originate or any of the other modes and you press clear, which is a momentary button, it will reset all of the things that are currently active and then shut down the machine. The test button is a special button for procedures used by service personnel. Local works very similar to what you would expect in a normal private line teletype where you have local full control over the machine. With a data set, however, if you have it strapped for full duplex mode, local is far less than useful because there's nothing echoing your characters back. Nothing will ever get punched to tape or printed on paper. And then the buzzer release. So whenever the paper spool starts to get low on paper, it will trip a lever, which flips a switch, which starts a buzzer, and it lights up this light while the buzzer's going off so you can identify which of the machines is low on paper. If you press this button, it will latch and it will shut the buzzer off. Once the buzzer is off, it will stay off until the machine is cycled to clear, at which point this button clears and the buzzer comes back on to remind you to change the paper before the next call comes in. So with all of that said, how about we call some things with it? So because this is a 110 baud machine, and because 110 baud is very difficult to detect unless software has a way to check for it, and also because teletypes use 2-stop bits and electronic devices tend not to, we will need to connect to my annex. The annex terminal server will be set to 110 baud, so it just assumes 110 baud, and it will be set to 8N2. Once we're connected to the annex, this will let us either grab another serial port for another modem, or it will let us telnet to a host. In either way, this ends up working very much like the central office equipment that I mentioned earlier, where it's doing speed conversions among other things. Okay, so now that we're connected to the annex, how about we call the BBS with it? Well, that was fun. How about we try calling RMAC to Versadial? Okay, that was great. Now, let's try connecting to a Linux system, and then maybe we'll go do some IRC as well. Well, there you have it. That is the oldest commercial design of modem that I have in my collection. This particular data set may not be the oldest modem in my collection. I have a couple that are actually older than this one's manufacture date. But as far as when the modem was designed, this one has the longest history. It took a lot of work for me to get this system working again. Between the data set and the teletype, it took quite a bit of effort, learning, going through documentation. There were so many things that were wrong with both of them, and they're so deeply intertwined with each other. It became very difficult to find the exact issues that I was having. But after a year of on-again and off-again trial and error, I finally got to a point where I had a breakthrough and recently got this machine back up and going. So I decided, since this is an old modem, probably the oldest modem that's ever been featured on YouTube, I figured I would give it a shot and put it up as the Modem Monday. There's probably still something crazy going on with this system, but it does what I need it to do, and so I'm not too worried about diagnosing anything else with it. It works for my needs. So I hope you enjoyed the explanation of this 50-plus-year-old modem and teletype, and I hope you'll join me again next month for another Modem Monday. Be sure to click like and subscribe to see more. Leave me a comment. I'd always love to hear what you have to say about what I'm doing here. Until next time, I hope you're having a happy Modem Monday. Bye, y'all.